Hello, welcome back to my channel and welcome to this episode specifically about the forward rescan rule in SAS. Now I have wrapped up my video, series of videos on the SAS base contents called SAS from Scratch. You can find that on my channel as well. And I need something new to keep myself busy with so that I don't irritate my wife too much and she decides to walk out on me. Joke. Please clap. Now I'm going to be looking at the forward rescan rule today, which is a process or a method used by SAS to resolve macro variables over several passes. So what that means is we've seen, for example, in the SAS base videos that I made, how you can resolve a macro variable. You use the let keyword, you point a certain macro variable to a certain value, and SAS will resolve that for you. Now that happens in a single pass. We can use SAS to have multiple passes over a block of code, macro code, and it can continuously resolve things that are preceded by multiple ampersands. And there's a particular way in which SAS does this. SAS will process the piece of code from left to right. So for example, I'm going to start with some code because I think that's the best thing to do. So let's go back to our old friend, the SAS help.cars dataset, and we're going to just load in all of the cars into a numbered macro variable. And so if we say here select distinct make from SAS help.cars, we're going to select that into some macro variables with the into keyword. And we're just going to reserve car1 to car 999. Now there's not actually 999 cars in this data set. That doesn't matter because SAS is only going to reserve the space for the number of cars it needs. So I think there's less than 40 in here. And so anything from car 40 to car 999 will just not be reserved. So I'm going to run this. And while I'm at it, we can actually figure out what the number of cars are with this handy sqlobs keyword. And so what that does is every time you, apologies if you can hear my dog, every time you run a SAS SQL statement, the last number of observations that SQL statement returned gets put into this macro variable called sqlobs. Now you want to be careful if you've got one SQL statement with multiple, selects in there. I believe that's going to be the very last one every time that gets put in there. But in our case here, we've got one select statement, so this sqlobs is going to give us the distinct number of makes that we have in our SAS help.cars dataset. So let's run this, see what happens. So this is all of the distinct makes in the SAS help.cars dataset. And if we go and look at our log, you'll see that the sqlobs variable has returned 38. Now this is a perfect example of SAS doing a single pass, the macro language resolver doing a single pass over the macro variable because there's only a single ampersand here. Now we have a number of macro variables in our symbol table, and I'm not going to use it right now, but you can run this piece of code for yourself. I think user will do. If the user symbol table doesn't work, use the global one. I'm not going to run this because if you are using SAS Studio, if you're using this SAS on demand for academics like I am, that's also going to display personal information like your IP, for example. So I'm not going to run this, but you can run this. And what you're going to see is there's going to be a symbol for car 1, and it's going to say, well, what's the first one in here? It's going to say Acura. There's going to be a symbol in the symbol table for car 2. I'm going to say Audi. And so what we want to do is say, well, let's loop over car 1 to car 38 in our case, and let's just print that out to the log. And something that's going to make our lives easier, I'm going to put it right at the top, is some of these macro helper options. So they're going to be mprint, mlogic, and symbol gen. And if you're new to using SAS macros, or if you've got a particular bit of macro code that's got you stumped, then these options are super helpful because they show you what symbols resolve to. They show you certain, so like mprint and mlogic will show you things like your loop indexes, what they're resolving to, etc., etc. We'll see some examples of that now. So we've got our distinct makes into car 1 to car 999, and what we're going to do now is just print them. So I'm just going to make a very quick loop here, and I'm just going to put some code in here that says do I is 1, 2, and don't forget, if you're dealing with macro stuff, the keywords have to be preceded by a percentage every time. So the do, the to, the end, that all has to be preceded by percentage signs. And so we're going to go from 1 to the number of observations that we've just seen goes into that sqlobs variable. And we are simply going to put each car number that make to the log. And the way we do that is to say, well, double ampersand for car, single ampersand for I. And this is a very good example and a very easy example of multiple passes over the macro code. And so the way that SAS is going to resolve this is SAS is going to say, and I'm going to type it out here as well just in case it's useful. Passing from left to right over this bit of code, every double ampersand becomes a single ampersand, and every single ampersand is resolved. And so what that means is if SAS encounters this piece of code that we've put here, so it has car I, it's going to pass from left to right. Our double ampersand here becomes a single ampersand, so it becomes ampersand car, and ampersand I is going to become 1, or it's going to become 2 or 3, etc. So that's what the function of that do loop is. And then SAS knows it's not done because we still have ampersands in the code. And on the second pass, when SAS comes through, it's going to say, okay, well, let's look at what car 1 resolves to. And we've already said, if we look at our code up here and we look at our results, we know that car 1 is going to resolve to Acura. And that's what is going to happen step by step in this bit of code that we've got up here. Now, of course, I is going to go from 1 to 38, so it's also going to resolve car 2, car 3, car 4, and so you're going to get Acura and Audi and BMW, etc. So it'll do that left to right. Every double ampersand becomes a single ampersand, and if it has a single ampersand, that is resolved. And then SAS goes and checks, is there still outstanding ampersands, and it will do another pass, and it will do this until the point where there are no more ampersands remaining to resolve. So if we run this, I'm just going to, let me run the whole thing because we want these options as well. These are our results. We know that our stuff is going to be in the log, so let's go back up. And you'll see from here, mprint, mlogic, symbol gen, these options that I've put in here now give us very useful information in the log. So symbol gen, for example, tells us that sqlobs resolves to 38. So that's the number of car 1 to something that was reserved in the symbol table. So this is actually no longer necessary for us to debug because symbol gen helps us to debug that. Mlogic, on the other hand, now tells us that it's beginning the execution of this print cars macro. It tells us that sqlobs resolves to 38, which is here, which is the endpoint of our do loop. And it tells us information about the do loop itself. Our index variable is I, and that start value is 1, stop value 38, and we are now at the first value for I, which is 1. You'll see as well, symbol gen tells us that this double ampersand resolves to a single ampersand, and that is then left for the next pass over the code. And it also tells us that macro variable I, because it has only a single ampersand in front of it, resolves to 1. And then on the second pass, we now have ampersand car 1. That resolves to Acura in the symbol table, and our put statement gives us Acura. The loop then continues and says, okay, index variable is now 2, and the loop iterates again. Same story. We start with ampersand, ampersand, car, ampersand I. This double ampersand becomes a single ampersand, and ampersand I, because there's only a single ampersand, resolves on this pass to 2. And on the second pass, ampersand car 2 resolves to Audi. And if we go, we can go and look that up in the symbol table as well. So this is one of the easiest examples of the forward rescan rule. Now, something else I want to look at is just to make sure you understand how to, if you see hundreds of ampersands, that you're able to resolve that by yourself. And so I'm going to start with a second example here. And I'm just going to give us a bit of room with a line so that we know that this is now a new section. But what I want to do is say, let's make a macro variable called 1. We point it to 2. Let's make a macro variable called 2, and we point it to 3. Let's make a macro variable called 3, and we point it to 1. So you can see we've got this circular reference here now, where if we resolve things, it's going to go 1 to 2 to 3, and back to 1, and then the loop starts over. And what I want to do is just work through something like this, where we say, okay, what happens if this is our macro? What happens if we've got 2, 3, 4, 5, 6, 7, 8, 9, 10 different, macro variables? So let's do that. Let's see what happens. And I'm just going to, so that's 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to put a bunch of ampersands in front here. This is 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, and then this one has 10 ampersands. And the other thing that I want to do is we are going to just figure out how many or how this is going to resolve, and we're going to do it on paper before, or I say on paper, we're just going to do it by hand before we let the SAS macro parser do it for us, because that's the best way we're going to know whether we understand what's happening or not. It's a good way for me to understand if I know what's happening while I'm presenting this course. So this one is, so let's run this first. So we have it in our symbol table. 1 points to 2, 2 points to 3, and 3 points to 1. Now, the first one is very simple. We're going to resolve 1 and it's going to go to 2. Very easy. So we know that this one is just going to go immediately to 2. Let's add some spacing here so that it's more easily visible, I think. Okay. Second one, we've got double ampersand and 1. What do we know? We're going to pass from left to right. Every double ampersand becomes a single ampersand. Every single ampersand will be resolved. So we know that these 2 ampersands are simply going to become 1 ampersand. That's the first pass done. Then on the second pass, we have ampersand 1, which resolves to 2. So that one is going to be 2 as well. On the third pass, we have 3 ampersands and 1. And this is going to give us, let's go back to first principles here. Every double ampersand becomes a single ampersand. Every single ampersand is resolved. So we're working from left to right. We have 2 ampersands here, becomes a single ampersand. We have a single ampersand and a macro token here, which means this is resolved to 2. And from 2, we know that 2 maps to 3. So this one is ultimately going to give us 3. Now, on 4 ampersands, working from first principles, left to right, we encounter 2 ampersands, they become 1 ampersand. We encounter 2 more ampersands, they become 1 ampersand. And then this macro token is not resolved, so it remains as is. We encounter 2 ampersands, that means we get 1 ampersand. And the macro token is not resolved on this pass. On the next pass, we have ampersand 1, which resolves to 2. I hope the pattern's starting to become clear. Now, moving on to 5 ampersands, we have 2 ampersands, 2 ampersands, and then a single ampersand followed by a macro token. So this one is going to become 2 ampersands become 1. The second batch of 2 ampersands become 1. And ampersand 1 will resolve to 2. The double ampersand becomes a single ampersand, and the macro 2 is not resolved on this pass, so it simply gets appended. And on the last pass, we have macro 2 points to macro 3. Now for 6, 1, 2, 3, 4, 5, 6, I'm going to go a little bit faster. We know that every 2 ampersands becomes 1 ampersand, so we're going to be left with 3 ampersands because we have 3 batches of 2 ampersands. And this should be 1, apologies. And then we are left with this 3 ampersands and 1. We know that 2 ampersands, these 2 right here, are going to become 1 ampersand, and ampersand 1 resolves to 2. And that gives us 3, because ampersand 2 will resolve to 3. How many have we got? 1, 2, 3, 4, 5, 6, 7, and then 1. So we have here that we have 3 batches of 2 ampersands each that will each become 1 ampersand, and ampersand 1 will resolve to 2. So we have 1, 2, 3, and ampersand 1 has resolved to 2 because there was a single ampersand and a macro token. On this one, we see that we have a double ampersand, which resolves to a single ampersand. And we have ampersand 2, which resolves to 3. And then we have single ampersand 3, which resolves back to 1. Easy. Then we have 8 ampersands. 1, 2, 3, 4, 5, 6, 7, 8. 1, because we have 8 and we have an even number, we know that nothing's going to be resolved on that pass. And that's important. Keep a hold of that thought. If you've got an even number of ampersands, they don't get resolved on that pass, because that's something important we're going to be looking at in a little bit. So we know that these 8 ampersands are going to become 4 ampersands and 1. 4 ampersands are going to become 2 ampersands and 1. Again, why? Because we simply go left to right and replace every 2 ampersands with a single ampersand. And 2 ampersands become 1 ampersand, and ampersand 1 resolves to 2. I'm going to just do these ones, I guess, in my head because I think it'll be simpler. Well, no, I'll have to talk through it because otherwise I'm not going to be able to figure it out. So we know that we've got 1, 2, 3, 4, 5, 6, 7, 8 ampersands here. So we've got 8 ampersands, so we've got 4 of 2. That's just going to become 4 ampersands, and 1 resolves to 2. So we have 1, 2, 3, 4, and 2. Then 4 ampersands become 2 ampersands, and 2 is not resolved because there's not a single ampersand that's left for it. And then 2 ampersands become 1, that's 2, and 2 becomes 3. Then the last one is 10 ampersands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, and that becomes 5 ampersands. And what does that tell us? Well, here we've got our 2 sets of 2, which will just resolve to single ampersands, and we've got ampersand 1, which resolves to 2. So we've got 2, and that resolves to 2 again, and that resolves to 3. Now, if we go and actually look at what happened with 5 ampersands and 1, which we already did up here, we see that it has also resolved to 3. Now, there's something very important to keep in mind here. And that is that when you've got double ampersands, you're essentially postponing the resolution of the macro token. Because it can only resolve when there is an odd number of ampersands. And so I want to put in another new block of information here. If I'm smart, I'll just copy and paste this. Come on. There's something we have to keep in mind here, which is we can see that at odd numbers we are actually resolving something. With even numbers of ampersands preceding a token, that resolution is being postponed. And there's a certain pattern that you'll be able to see, and one that you can go and look at it mathematically as well. And there's some papers on it. There's a particular paper. I've got it open here. Give me a second. Give me 1 second. I just want to bring this paper up. Hopefully without too much of a fuss. Okay, so here's a paper by Michael J. Malter that I found quite. This is one of the better ones. There's quite a few. In my opinion, there's a lot of resources out there on the forward rescan rule. My personal feeling is not everybody who talks about it has necessarily the same understanding of the, well, throwing shade on people who've actually published papers. I haven't published a paper on the forward rescan rule, but it sometimes feels to me that not everyone who publishes these papers and website articles always really fully understand what they're talking about. Now, this paper I felt was quite good. It has a good understanding of it. It has good examples of it. And I would encourage you to read this paper if you can. It is available on the SAS site, part of their resources and things, but you can look this up. It should be fairly easy to find just with this information. Now, something that happens is how many times do we, or how many ampersands does a do you need? How many ampersands do you need to resolve something? And the question, or the answer to that is, it depends on what you want to do. If you want something to resolve on every run that you do, you're going to have to have there's a particular number of ampersands that you want. And the formula for that is, so on step number n, you want 2 to the n minus 1 ampersands. And so what that means is, on step 1, you've got 2 to the 1 is 2 minus 1 is 1. You've got 1 ampersand. So if you want something to resolve on step 1, that's how many you need. If you want things to resolve onto step 2 as well, you're going to need 3 ampersands, 2 to the 2 minus 1. Why? Because you've got that's a good way of putting this. You definitely, if you look at this as well, so 1 resolving to 2 happens with 1 ampersand. 1 resolving to 2 resolving to 3 happens with 3 ampersands. The next one is, so S to 3 is 2 to the 3 is 8 minus 1 is 7. And if you look at where we had 7 ampersands, that one resolves 1, 2, 3, 1 directly, full loop. And so you get this pattern, which is 2 to the n minus 1. And why does 2 to the n work? Well, because this method of resolving every 2 ampersands to 1 ampersand is essentially a log base 2 operation. It's a sort of a binary, what is the word I'm looking for? My computer science education escapes me now. But you've got a log 2 operation, which essentially, if you've got 32 ampersands, it'll take you basically 5 steps to get to a single ampersand again, because it's going to go from 32 to 16. That's step 1. It's going to go from 16 to 8 in step 2, 8 to 4, 4 to 2, 2 to 1. And so that's why 2 to the n here also, it makes sense, because we're dealing with a log 2 operation in reverse. However, what this does is it will definitely resolve on every step. So if you look at number 7 here, 10, 9, 8, 7. If you look at number 7 here, it resolves something on every single step. And we don't necessarily want that, because if we go back to our earlier example, we specifically use the double ampersand here because we said first let I resolve to a particular number, because our symbol table contains car 1, car 2, car 3, and we need to make sure that we can resolve to that first before we try and look it up. If we had, for example, let's do something like this. Car 1 becomes Acura. If we, for example, had here car and I, then it would simply say car couldn't be resolved because there's no macro variable called car, and I would resolve to 1. If we had 3 ampersands, then what would happen here is, now this is a good question, but I would resolve to 1. The 2 ampersands become a single ampersand, and ampersand car wouldn't resolve. Now the question becomes, what does SAS give back to you? I don't know. Let's find out. It might end up just accidentally resolving, because it might just give you back car instead of ampersand car. Okay, so it doesn't resolve. It doesn't resolve I in this case because we're not inside the do loop, so it doesn't exist. And it does not resolve car, so it just gives us back that car there. So this is messy. Maybe we should put this into, let's put this into the do loop and see what happens so that I can actually resolve. Okay, so it works, but it works by accident. And the reason for that is, so you can see double ampersand resolves to a single ampersand. Ampersand car does not resolve, so it just gives back car. And at the end of the day, by accident, you get ampersand car 1. But that's, you know, that's just an accident, and that's not the way we want to be programming. The better way of doing it, the correct way of doing it, is to put 2 ampersands here and know that nothing is going to be resolved on this pass. And the reason for that is that it'll pass, make this a single ampersand, resolve ampersand I to an actual number, 1, 2, 3 in the meantime, and then it will, at the end, resolve ampersand car and a particular number, which is in the symbol table, because that's how we placed it in there. And so it is, these formulas are nice to have, but they are not necessarily accurate all the time for what you want to do. It's better to have a good understanding of how SAS is going to resolve these things than blindly saying, okay, on step 2, I'm going to put 3. Because we saw here that 3 will work, but in a roundabout, almost wrong way, accidental way, it ends up resolving properly. And so a better way of doing it is just trying to sit and figure out when you want certain things to resolve. So this has to resolve on the first pass, this has to resolve on the second pass, this has to resolve on the third pass. But this is a very useful formula for giving you an idea of, you know, more or less how many ampersands you're kind of looking at. Now, I have heard people, I think there's a bit of a joke in the SAS community, which is just keep adding ampersands until it starts working. Funny as that may be, that's also not the way we want to program, because that's not scientific. Now let's look at one more example, and this is the last example that I have for today. And the way I'm going to do it is I'm going to just manually specify a couple of courses. So for example, we're going to have Maths 101, we're going to have Physics and Chemistry 101 as well. Course 3 is Chemistry 101. And then I'm going to make a description for each of these. So we're going to say, well, let Mathematics 101 be Introduction to Calculus. Let Physics 101 be Fundamentals of Newtonian Physics. I assume that's what you do in Physics 101. I can't remember, it was a long time ago. And Chemistry 101, I was too stupid for chemistry. So in my mind, the only thing that you chemistry guys end up doing in the course is you look at the periodic table and you have some fun with Bunsen burners. Perhaps Tina Turner is also there with her Bunsen burner. And what I'm going to do is make a loop here so that we can, similar to what we've done for the cars, you know what, let's not reinvent the wheel, we've already done this. So we're just going to say here print courses, and we are going to do 1, 2, 3 just manually because we only know there's 3. And so let's do certain things. We can do we know we have to figure out what I is. We have to figure out what, and this one is still simple because it's course I. So this is similar to the cars one. So we had car 1, car 2, car 3. Now we just have course 1, course 2, course 3. So we have I and we have whatever, you know, course 1, course 2, course 3 points to. And I'm just going to run this so that we can keep track of what's happening. And if we look at this, we'll see that I resolves to 1 and put I gives us this 1 back. If we look at the second bit here, we have ampersand, ampersand, course I. We have the double ampersand becomes a single ampersand. I goes to 1. And then we know that course 1 resolves to Maths 101. And we put it there with Math 101. The same thing happens for Physics 101. The same thing happens for Chemistry 101. Now, if course 1 points to Math 101 and Math 101 points to Introduction to Calculus, the question here becomes how many ampersands do we need if we wanted to have the description printed? Now let's think about this logically. We essentially want to, on the third step, do this. So we're going to put ampersand Math 101 to point to Introduction to Calculus. And this is where you've got to keep your head about you. Because we know it's around the third step that we want this to happen. How many ampersands will we need to make it happen? Let's work it out on paper first. And if you've been doing this for a while, you'll have a good idea of what you're looking at. But until you have, instead of just throwing ampersands at the wall until something sticks, let's try and work it out. So we know that ampersand, ampersand, course I, is just going to give this back to us, these course codes. So let's add an extra ampersand. Let's say we've got 3 ampersands, course I. What is that going to give us? That's going to give us double ampersand, which becomes a single ampersand, this one. And then it's going to try and resolve course, and then it's going to try and resolve I. We know that's not going to work. Let's put 4 ampersands here. And so why do we immediately know this isn't going to work? Because there's nothing just called course. It always goes with a number in our symbol table. So if we had, for example, let course equals blah, 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 that would actually end up resolving, but we don't. So it's not going to resolve. So with 4 ampersands, we know we're going to get 2 and 2. We're going to get just 2. 4 ampersands become 2. We're going to have course, and ampersand I is going to resolve to 1. And up here as well, that should have been 1. So 2 ampersands, course, and 1 is going to become single ampersand, course 1, which is just going to become Math 101. So these 4 ampersands give us the same result as 2 ampersands, but it just delays us by a round, by a pass. And we can start to see where this is going. Let's then take 5 ampersands. We immediately know 5 ampersands aren't going to work because we're going to have 2 ampersands and we're going to have course and we're going to have 1, and this will not resolve. So same as above, that gives us an unresolved token. Now 6 ampersands, course and I. What does this give us? 6 ampersands become 3 ampersands. Course and 1, because ampersand I will resolve to 1. And these should actually, there shouldn't be spaces here, just bear with me for the purposes of this explanation. These 2 ampersands at the start become a single ampersand. Ampersand course 1, should be together, let me do this. Ampersand course 1, this one is not going to resolve, that is separate. I just want to make sure that this is clearly presented. That's ampersand course and 1, which will not resolve. So 2 ampersands become a single ampersand. Ampersand course 1 becomes math 101, and math 101 gives us this introduction to calculus. So we know from what we've done here that 6 ampersands should give us the correct answer. 1, 2, 3, 4, 5, 6, course, ampersand I. And we did that. We didn't just throw stuff at the wall hoping it sticks. We worked that out for ourselves in our heads. We checked how SAS would interpret it, and then we went and put it in the code, which is a much better way of doing things. Now if we run this, you will see, so there we have course 1 resolves to maths 101. There's actually a whole lot. So I resolves to 1, fair enough. This is where we have math 101. And we then start with the big one, which is the number of passes that go through every time. So we have the 2 ampersands become a single ampersand 3 times, because there's 3 batches of 2 ampersands. Then it approaches ampersand I, resolves it to 1. And then we have 2 ampersands become 1. We have that ampersand course 1 becomes math 101, and ampersand math 101 resolves to introduction to calculus. And that is essentially, well, we've done 3 examples, but that's essentially the forward rescan rule explained in a not too short, but short-ish video. Very useful way of doing things. If you would like a particular example of how you can use this in the industry, is if you've got, say, subjects to be plotted. Let's say you've got subject conks to be plotted, for example. One way you can do that is if you can place them in a macro, the different subjects. So if you've got, for example, okay, well, it's ABC 001 and then ABC 002, and then, for example, maybe you've had a dropout and it's now actually ABC 004, you could do something like, you know, proc sql quit select distinct, use subject ID to subject 1 to subject 999. You can loop over these subjects, and every time you can filter on, for example, because these are individual, right? So you can filter on your concentration data, and you can say, okay, well, you know, data conc subset is, just say set concs where use subject ID equals, how will we do this? We'll do subject I. And then this is going to, you know, return ABC 001, ABC 002, ABC 004. And with this conc subset, you can then plot each subject individually, because every time your macro is going to loop over this data set, it's going to make a new subset const dataset. And that's just one example of where you can use it in your day-to-day way of working. That wraps it up for me with the forward rescan rule. As always, if there's something I'm missing, if there's anything else you'd like to add to the conversation or ask a question, please leave a comment below. You're also welcome to give it a like if this was useful, and you are welcome to subscribe, because I don't know how regularly I'll be doing some of these videos, but I have been enjoying the SAS from Scratch series that I did, and I'll probably keep doing something similar for the more advanced topics as well. This being part of the advanced curriculum, SAS advanced curriculum, the certification, and I might do something very similar to this, where instead of trying to take the entire curriculum and go over the entire SAS advanced prep guide, I might just highlight certain aspects of, for example, macros or arrays or hash objects or something, and then make it a much shorter series. But yeah, that's it. That's it from me. Until next time, I would like to say thank you very much for watching, and have a good day. Cheers. Bye-bye.